As mentioned in the first part of the introduction, this is clearly an important distribution. It's important as very many processes, both natural and man-made, lead to this distribution. It is a continuous distribution, which means that the types of data it handles are height, weight, and time. In other words, continuous variables. It is called the normal distribution. Some of its features are the fact that it is symmetric about a mean value. Which means that the mean of the distribution is equal to the median of the distribution, which is equal to the mode of the distribution. It can be defined by two parameters. One of them is the mean, and we know that it is symmetric about this mean, and the other is to do with the dispersion. We measure dispersion with variance in this case, and so the parameters of this distribution are the mean and the variance. If x is a random variable following a normal distribution, we write that x follows a normal distribution with mean mu and variance sigma squared. So to reiterate this, for a normal distribution, the mean and variance are called parameters. The distribution is defined by these two parameters. Here we can see two different normals. They clearly have different means. We call the mean of the red one mu1 and the mean of the blue one mu2. Here we can see that these two have the same shape. They have the same variance, and this is underlined by the fact that they have the same height. If we were to call this one x and this one y, then we could write that x was normally distributed with mean mu1 and variance sigma squared, and that y was normally distributed with mean mu2 and variance sigma squared. Note the same variance, since these two have the same shape. It is only their mean that is different. If we consider these two normals, clearly they have the same mean. Let's call it mu. If we consider their variance, the blue one is less spread out than the red one. We'll call the standard deviation for the blue one sigma 1 and for the red one sigma 2. If we call the red one y and the blue one x, then here we can write that x follows a normal distribution with mean mu and variance sigma 1 squared, and that y follows a normal distribution with mean mu and variance sigma 2 squared. Note here that the mean is the same. The difference between these two distributions is their variance.